technologies we develop here at CERN, they do change the world. We understand a lot, but there are really big questions that we don't know the answer to.
Underneath the French-Swiss border, a multi-billion-dollar machine is quietly humming, and the data it's spitting out has sent a shiver through the global scientific community. Feisty years and humanity's ultimate rulebook of reality, the standard model of physics has perfectly predicted how our universe behaves. But right now, inside the blinding flash of particle collisions, something impossible is happening. A microscopic anomaly is breaking the established rules of nature, signaling that our understanding of the universe might be fundamentally wrong. The physics-defying ghost, the penguin decay anomaly. First, let's shrink ourselves down and look inside the most complex machine humans have ever built, the Large Hadron Collider. This massive 17-mile ring of superconducting magnets buried deep beneath the Earth is basically a cosmic time machine, violently smashing protons together at 99.999999% the speed of light to recreate the conditions of the early universe. Most of the time, these high-energy car crashes result in exactly what the rulebooks say they should. The particles shatter, energy converts to matter, and everything follows the script. But hidden inside a specialized multi-thousand-ton detector known as the LHCb experiment, a tiny subatomic rebel has been caught misbehaving. The particle causing all this absolute chaos is called a beauty meson, or simply a B meson. These are highly unstable, short-lived bits of matter that exist for only a fraction of a trillionth of a second before they violently decay, splitting apart into lighter, more stable particles. Now, according to the absolute ironclad laws of our standard physics framework, these B mesons are supposed to decay like clockwork, following a rule known as lepton universality. Think of it like a cosmic vending machine. If you put the exact same amount of energy in, the universe is supposed to hand you electrons and their heavier cousins, muons, at a perfectly equal rate. It's a beautifully simple, symmetrical concept. Nature isn't supposed to play favorites. It should be a perfect 50-50 split, as predictable as a coin flip. But it isn't, not even close. When scientists at CERN started digging through the data from a specific, ultra-rare type of transformation called a penguin decay, that beautiful cosmic symmetry completely shattered. The math behind this specific decay maps out a loop pattern that looks vaguely like a penguin, which is how it got its bizarre, kind of funny name. But what's happening inside that loop is no joke. The data revealed that these B mesons are actively favoring electrons, choosing forbidden pathways and ignoring the muons entirely. It's the equivalent of flipping that coin 1 billion times and having it land on heads 70% of the time. It simply shouldn't happen unless the coin is rigged or some invisible hand is pushing it over. So who is rigging the subatomic deck right under our noses? Physicists are currently tracking 2 major suspects that could be acting as this hidden, physics-defying ghost, and both options are wild. The first suspect is a completely theoretical particle called a leptoquark. If leptoquarks are real, they are an entirely new species of matter. They would act as a strange, unprecedented bridge between 2 completely different families of particles that normally never mix or talk to each other. In the chaotic split second of a particle collision, these leptoquarks would crash the party, interfering with the B meson as it breaks down and forcefully steering the decay away from muons. It's a ghost particle we've never seen, doing things we didn't think were possible. But the second suspect is even more radical, and it honestly sounds like science fiction, a 5th force of nature. Right now, as far as science is concerned, the entire universe is governed by just 4 fundamental forces. You've got gravity, keeping your feet on the ground, electromagnetism powering your phone, and the strong and weak nuclear forces holding atoms together. Every single thing that has ever happened in the history of the cosmos, from the Big Bang to the text you sent 5 minutes ago, happens because of those 4 forces. Discovering a 5th force would change absolutely everything. It would mean our universe has a hidden engine running beneath the surface, a secret physical law pushing particles around in ways we have been completely blind to since the dawn of human intelligence. It would mean the standard model isn't just missing a minor footnote. It means the very foundation of how we explain reality has a massive, glaring hole in it. This penguin anomaly is the first real physical proof that there is an entire realm of nature operating just beyond our sight, defying our laws because it answers to a completely different master. It forces us to confront a deeply unsettling but thrilling realization. The rules we thought were absolute might just be local customs in a much bigger, stranger universe. But if our current physics is failing to explain these microscopic glitched decays, what else is it completely blind to? What other massive secrets are hiding right in front of us, masked by the limitations of our old rulebooks? The cosmic blind spot, cracking the dark matter vault. If you think a glitch in a microscopic decay loop is wild, brace yourself, because the problem gets much bigger, literally. The reason physicists are so quick to jump on these subatomic rule breakers is that they are desperately looking for a doorway into the darkest, most embarrassing secret in modern science. We have absolutely no idea what the vast majority of the universe is actually made of. Think about that for a second. Every galaxy, every burning star, every nebula, every planet, every ocean, and every single human being to ever exist is made of normal, visible matter. Atoms, protons, neutrons, and electrons. But when you add up all of that physical stuff, everything we can see, touch, and measure with our best telescopes, it accounts for a pathetic 5% of the cosmos. The rest, it is completely invisible, totally silent, and utterly unexplainable by our current laws. Scientists call it dark matter, and according to our precious standard model, it shouldn't even exist. Our ultimate rulebook completely leaves it out of the equation, as if most of reality is just a giant cosmic typo. For decades, we've known dark matter is out there because we can see its gravity pulling on the universe like an invisible puppet master. When you look at how galaxies rotate, they spin so fast that by the laws of normal physics, they should violently rip themselves apart and scatter their stars into the deep void of space. There isn't enough visible mass to hold them together, but they don't rip apart. Something massive, heavy, and totally unseen is acting like an industrial-strength cosmic glue, holding the structures of our universe intact. We can see its massive gravitational shadow bending light across the cosmos, but we cannot catch the actual particle responsible for it. That is where CERN's upgraded powerhouse comes into play. To catch a ghost, you have to build a trap capable of creating conditions so extreme that the ghost has nowhere left to hide. Physicists at CERN are leveraging a brutal, high-stakes tactic to solve this cosmic blind spot. By smashing protons together harder and faster than ever before, they aren't just looking for what's already floating around us, they are trying to forcefully shock entirely new matter into existence. According to Einstein's famous equation, E equals mc squared, energy and mass are just two sides of the same coin. Matter is just locked up energy, and energy is just liberated matter. If you jam enough kinetic energy into a single, infinitesimally small point in space, that energy will violently condense into brand new exotic mass. The goal at the Large Hadron Collider is to trigger a collision so fiercely energetic that it forces a genuine, heavy, dark matter particle out of the theoretical mathematical equations and into our physical reality. But this raises a glaring, almost impossible question. How do you detect something that is completely invisible and passes through solid matter like a phantom? The answer is brilliant in its simplicity. You don't look for the particle itself, you look for what it leaves behind, or more accurately, what it takes away. Imagine watching a high-stakes game of billiards. Two balls smash into each other at the center of the table, and based on basic math, you expect them to bounce off in perfectly predictable opposite directions. But suddenly, one ball flies off violently to the left, while the other ball just vanishes into thin air. Meanwhile, the table itself shakes as if an invisible force clearly pushed off to the right. light. You didn't actually see the missing ball, but you know with absolute certainty that it was there because the momentum and energy of the table are completely unbalanced. That is exactly how CERN hunts for dark matter. The massive detectors measure the precise energy and momentum of the protons right before they collide, and then they measure the energy of the debris flying outward after the crash. If a massive chunk of that energy mysteriously disappears into thin air, leaving an empty void in the calculations, it means a dark matter particle was created. It means it slipped right through the detector's solid steel and concrete walls without leaving a scratch, escaping into the night but leaving behind a distinct mathematical fingerprint of missing energy. Finding this missing energy would do far more than just fill a frustrating gap in our textbooks. It would violently smash open the boundaries of known physics. It would prove that the standard model isn't the final destination of human knowledge, but merely the introductory chapter of a much vaster library. We would finally be able to look at the dark ocean of the night sky and understand what we are actually staring into. But hunting for invisible matter across the vast, infinite cosmos is one thing. What happens when the machine doing the hunting starts generating its own unexplainable, ghostly anomalies right inside the accelerator beam itself, trapping the ghosts inside the accelerator? When we think about CERN hunting for things that defy the laws of physics, we usually imagine scientists looking outward into deep space or staring down at the debris of smashed atoms to find a brand new particle. But sometimes the most terrifying, rule-breaking anomalies don't come from the outer universe. Sometimes they are generated by the machine itself. For over 2 decades, physicists at CERN were quietly haunted by an invisible, unexplainable disruption deep inside the accelerator complex. They couldn't see it, they couldn't measure it, and their standard equations couldn't fully account for it, but they could see the damage it left behind. They called it the ghost in the machine. To catch this specific phantom, we have to look slightly upstream from the main Large Hadron Collider at a massive 4-mile ring called the Superproton Synchrotron, or SPS. The SPS is the ultimate launch pad. Its entire job is to rev up particle beams to extreme intensities before injecting them directly into the main LHC. But for years, scientists noticed a frustrating, chaotic glitch. As they pushed the machine to higher and higher intensities, particles would suddenly start straying from their tightly controlled paths. They would drift off course, degrade unexpectedly, and simply vanish from the beam, limiting the performance of major physics experiments. According to standard, linear accelerator physics, these particles should have stayed locked in their magnetic tracks. Instead, an unseen, chaotic force was actively pulling them into the void. It took a groundbreaking international collaboration and a staggering computational effort to finally track down the culprit, a highly complex, non-linear phenomenon known as a coupled resonance structure. To get what a resonance structure actually is, think of pushing a child on a playground swing. If you push at the exact right moment, your timing syncs up with the swing's natural frequency, and the swing goes higher and higher. That is linear resonance. But inside a particle accelerator, the magnets that steer the beam are not perfectly uniform. They have tiny, microscopic imperfections. When a high-intensity beam passes through these imperfections over and over again, but here is where it enters the realm of the bizarre. This wasn't happening in the normal flat dimensions we are used to. The ghost resonance inside the SPS wasn't just pushing particles left or right or up and down. It was a coupled resonance operating entirely within a 4-dimensional phase space. It was an anomaly that bound horizontal and vertical motion together into a complex, multi-dimensional web. Because human beings and standard monitoring equipment are fundamentally limited to thinking and measuring in single planes, this 4D resonance structure remained entirely invisible to direct observation for more than 20 years. It was a presence inferred strictly from absence, a mathematical phantom that could only be traced by the destruction it caused to the beam. To finally trap the ghost, physicists had to completely revolutionize how they monitor the accelerator. Using ultra-sensitive beam position monitors scattered all around the 4-mile ring, scientists tracked individual particle movements across roughly 3,000 continuous beam passages, measuring subtle deviations in both the horizontal and vertical planes simultaneously. By stitching this massive, multi-dimensional data map together, they did the impossible. They gave the ghost a definitive shape and a precise set of coordinates. For the very first time in human history, a coupled 4D resonance structure had been experimentally proven and visualized in the real world. This breakthrough was a massive victory for accelerator engineering, allowing scientists to develop mitigation strategies to keep future beams stable, bright, and intensely focused. But from a physics perspective, it proved something far more profound. It demonstrated that when we push matter and energy to their absolute extremes, the resulting nonlinear chaos behaves according to hidden, multidimensional mathematical structures that we are only just beginning to comprehend. The ghosts harming our experiments aren't random glitches. They are the natural consequence of physical laws operating in geometric spaces beyond our everyday perception. By successfully mapping this invisible 4D monster, CERN proved that humanity has the tools to decode the hidden, chaotic scaffolding of reality. But it also raises a brutal, ultimate question for the scientific community. If it took us 20 years of painstaking labor just to prove the existence of an invisible mathematical structure happening inside our own machinery, how on earth do we definitively prove that a microscopic glitch in a particle decay is a genuine, reality-shattering discovery and not just another multi-billion-dollar mistake? How to prove reality is wrong? When you are dealing with things that actively defy the known laws of physics, you cannot just announce a discovery because you saw something weird on a computer screen. In the high-stakes world of particle physics, skepticism is the default setting. If you want to stand in front of the global scientific community and claim that you have discovered a fifth force of nature, a leptoquark, or an invisible 4D resonance structure, you have to cross a brutal statistical finish line known as 5 sigma. Now we look at the mathematics of luck. Imagine you flip a normal coin 5 times, and it lands on heads every single time. You might raise an eyebrow, but you wouldn't assume the laws of probability are broken. But what if you flipped that same coin 100 times, and it landed on heads every single time? At that point, you would know with absolute certainty that the coin is rigged. In particle physics, a 1 sigma result is a mild, uninteresting hiccup in the data. A 3 sigma result is what scientists call an evidence of an anomaly. It means there is roughly a 1 in 350 chance that the weird data you are seeing is just a random fluke. For most branches of science, those are fantastic odds. If a medical trial showed a 3 sigma success rate, a substance would be fast-tracked to the public. But in particle physics, 3 sigma anomalies disappear all the time. They are often just statistical ghosts, temporary illusions created by a detector having a weird day. To officially claim a discovery, you must reach 5 sigma significance. That means the probability that your physics-defying anomaly is a random statistical fluke is less than 1 in 3.5 million. This extreme rigor is exactly why the scientific community is holding its breath regarding the penguin decay anomalies at the LHCb detector. For a while, the data tracking those rebellious B mesons was climbing steadily toward that legendary 5 sigma threshold, sending shockwaves through physics departments worldwide. But as more data poured in and scientists refined their complex calculations, the statistical significance wavered just below the definitive discovery line. Nature was refusing to give up its secrets without a fight. This high-stakes limbo is precisely why CERN launched a massive, multi-year engineering overhaul to trigger the next era of exploration. the High Luminosity Large Hadron Collider upgrade. By completely redesigning the superconducting magnets that focus the particle beams, scientists are vastly increasing the luminosity of the collider, creating far denser proton beams. Instead of a few 100 million collisions a second, the upgraded machine will produce an absolute avalanche of billions of subatomic car crashes every single moment. This staggering increase in raw data is the ultimate weapon against uncertainty. It will allow physicists to gather more particle collisions in a single year than they did in the entire first decade of the LHC's operation combined. With that kind of computational firepower, the statistical fog will be completely clear. The data will either brutally crush these anomalies as mere statistical flukes, or it will violently push them over the 5 sigma finish line, cementing them as absolute, undeniable facts that will rewrite our reality forever. The data pouring out of CERN is sending a clear, thrilling message to the next generation of minds. The true story of the universe is just getting started, and the most exciting chapters have yet to be written. If you liked this video, subscribe to the channel for more.